Hi, in this video we are going to study very interesting topic, the origin of quantum mechanics. Now, as we all are students of science and we find it very difficult that why the scientists have introduced quantum mechanics, or we can say that how it comes to their mind that there are quantas or photons. Now, we are going to see that what happened in 1800 to 1900. In 1800 to 1900, the scientists were working. They were working on different experiments and they all got some results. Now, and the phenomena which they got were completely new. Like they got to know about blackbody, the blackbody radiation, they got to know about photoelectric effect, and they got their results also, and that was completely new discovery for all of them. But they could not explain their results. They did their experiment, they got their results, they got their graphs, their charts, their results were completely correct. But they could not explain it that why they all are getting this kind of results. And mainly they all were dealing with light. At that time they all had to know that light is produced because of vibration of charged particles. Now we know that light is electromagnetic wave. That means electromagnetic field, electric field and magnetic field is there. Now if a charged particle is going to vibrate, obviously it is going to get electric field and magnetic field. That means accelerated particle or a particle which is vibrating is going to have EM wave, and that EM wave is light. And they knew that heat is what? Heat is energy, which is because of the random motion. Now if there is motion of charges, then that particle, that thing which is charged and is moving, that is vibrating, is going to have heat as well as light. Now there was an experiment which was done in between 1850 to 1900 that was named Blackbody Radiation. Now the scientist was doing that experiment, he got his results, he got a spectra of the body. What he observed was completely different from his mind's calculations. He thought the result in one way, but he got it in another way. So what were the results? They all kept on thinking, but still they didn't get any results. Even in 1887 there was an effect found which was given photoelectric effect name. It was observed by Hertz, but he also was not able to get why he is getting those kinds of graphs and those kind of calculations and all. But he said that the effect is true, but they didn't have any reason that why they are getting these graphs. In 1897, they got to know that there are particles called electrons by the cathode ray tube experiment. So in 1900, what happened? Planck suggested one thing. What he suggested? That he suggested that we are going to assume one thing, and this assumption is going to explain this blackbody radiation. And on the similar basis, what happened when in 1900 Planck suggested that he is going to assume which is going to explain this effect. So after 5 years, in 1905, Einstein said that I am going to use your assumption, but I am going to modify it further and I am going to explain this photoelectric effect. So those assumptions became a field of science which explained light. They both had assumptions for light only. Earlier the light was EM wave only. It was a wave which was produced because of the vibration of the charged particle, and there was heat because of the random motion. Now what they assumed? They assumed that light is not only a EM wave, or we say that earlier in classical mechanics, or we say till 1900, what they assumed that the light is formed because of vibration of charges. That means if they have a particle and it is going to vibrate, then the EM wave which is going to be formed will have frequency of this vibration only. That means this particle is vibrating with some frequency, and it will going to have the wave will going to have frequency of like this only, and the energy of each frequency frequency is going to be the same. But this assumption that each frequency will have the same energy was assumed to be wrong, and they said that there will be quantas of energy, that means energy which will be related with the light will depend upon the frequency in this manner. That means if the frequency of the light changes, that means energy of the light changes. Now this assumption was made to explain this blackbody, photoelectric effect and many more effects or the discoveries which were done earlier. So all this thing was actually assumed as a single thing, but further moving on and on, they got to know that there are so many things which can't be explained except they take light to be as this quanta. That means earlier the light was considered to be as EM wave, but if they take light as particle, then they are going to get these results. So that is why the reason the quantum theory was made, which explained their effects, their discoveries, and after, like we can say in 1911, the Rutherford scattering experiment told them that there is a thing in the atom called nucleus. So we can imagine if they didn't know what were electrons, what was nucleus, then how they could have got these results of photoelectric effect and blackbody radiations. So the assumption of this photon explained these experiments and their results were taken. So in the next videos we are going to study the blackbody radiation, the photoelectric effect, that what were the results of blackbody radiations and why they were not be explained by classical mechanics and how they get explained with the quantum mechanics. Similarly for photoelectric effect and other things.